Students, in the last lecture we have introduced the continuous time Fourier transform. Now in this particular lecture we are going to get more details about the Fourier transform. So this is what we have seen in our last lecture. We have identified the Fourier transform of this kind of box function, and we have seen that if there is a periodic signal in the time domain or in the spatial domain, we are going to have a continuous spectrum in the frequency domain. So isn't it interesting to know that this kind of spectrum is there for some kind of rectangular function. Now I told you that we cannot you can say measure, or you cannot accommodate a continuous signal on any computer or in any computational machine. So that signal needs to be discretized. So from that continuous signal, in my next lecture we will try to discretize our signals and try to take the Fourier transform of a discrete signal, which eventually called one process which is known as discrete Fourier transform. I hope that you all have some basic fundamental idea about this discrete Fourier transform, as you have gained the knowledge from our previous course of digital signal processing. So we're going to take a reference of that, and we're going to introduce the concept of one-dimensional discrete Fourier transform and two-dimensional discrete Fourier transform. Then this discrete Fourier transform can also be obtained from one very fast method, which we call it as a DFT matrix method, or a twiddle factor matrix method. So we're going to introduce that part also, and we're going to see like how that DFT can be calculated using a matrix method then. And since my image is a two-dimensional matrix or two-dimensional signals, so this DFT matrix is very computationally very fast when we introduce this DFT matrix over there. And if time permits, we will going to take up one or two properties of the DFT. In order to understand the basic operations on the image, we need to first understand the properties of the DFT. So we're going to take up either the separability property and the translation property at the end if time permits. So I hope that you will going to understand the concept more in more convenient way by applying the same thing on hands-on exercises. So hope to see you all in my next class. Thank you.